Okay, everyone, we're going to take a shot at one of these really scary limiting reactant problems. First thing you're going to need is a periodic table. You will probably also need a calculator, so have those handy. And you'll notice you're given just a very small amount of information. So the problem reads, if you're given 50 grams of NH3 and it reacts with 100 grams of O2, the first question we're asked to solve is, number one, how many grams of water are produced? So that's kind of what we're after for number one. To begin these problems, I like to go back to my equation and first of all check to make sure it's balanced, which it is in this case. So I'm going to move on. And I like to actually put what I'm looking for in my equation. So my unknown is going to be water, that's my x. And then I also like to write what I'm starting with. I'm starting with 50 grams of NH3 and I'm reacting it with 100 grams of O2. I don't know why, it just makes me happy. I like to see what we're given and kind of where we're going. So by doing that, almost immediately I can see I'm going to have to do two mass to moles to moles to mass calculations. I'm going to start with one with my reactant NH3 and figure out how much maximum water I can make. And then I'm going to do the exact same thing, only I'm going to start with my second reactant and go from mass to moles to moles to mass and connect my oxygen and figure out how many maximum grams of water I can make. So let's dive on in here, then we can compare our results. So I'm going to start with 50 grams of NH3 for no particular reason. Notice how I am using my units here. It's not just grams, it's specifically grams of NH3. First thing I'm going to do is convert to moles. 1 mole of NH3 has a molar mass of 17 grams. Where did I get the 17 grams from? That is my favorite question. This is the molar mass off the periodic table. So that first part is simply converting to moles. Then I have to look at my mole ratios because I'm going to want to connect my NH3 again back to my final product. That's what I'm after. I'm trying to figure out how many grams of H2O I can make. So let's look at our mole ratios. Because I have moles of NH3 here as my unit, I know I'm going to have moles of NH3 drop down in the denominator to cancel out, so that's exactly what I'm going to do. I'm going to put moles of NH3 here. And again, where am I trying to get to? Well, I'm trying to get to grams of water, but I can't go straight to grams because I don't have a conversion there, but I do have a mole ratio, so I'm going to go to moles of my product. That's what I'm really interested in. Now, where do I go to find these mole ratios? That's another one of my favorite questions. Where do I go to fill in my mole ratios? Oh yes, it's our coefficients. You have to look at the coefficients in your balanced chemical equation. So if I do that, I believe I should get a 6 up top and a 4 down below. Yes, you can simplify. It doesn't matter if you don't. You'll still end up with the same answer. I'm almost done here. Now I need to convert from moles of water back to grams. That way I can compare my two gram values. So I have moles of H2O up top as my unit. That means I have to have moles of H2O down below to match, and I'm trying to get to grams of H2O. So 1 mole has a molar mass of 18 grams, I believe. Where did that number come from? That just came from the periodic table. Now we're all set. My units are going to cancel beautifully. Everything's canceled out, and I'm left with grams of H2O. That's exactly what I want to see. How do I solve this? I know it looks really scary, but it's actually not that bad. If you punch in your calculator all of the numbers up top and multiply them together, it's 50 times 1 times 6 times 18. Then you're simply going to divide by everything that's in the denominator. Hit divide by 17, hit divide by 4, hit divide by 1, and you should end up with something around 79.4 grams of H2O. Awesome. It's great if you followed me this far, and I know some of you are really good with going from mass to moles to moles to mass, but kind of the hard part is almost analyzing what you just did. What did you just tell me? You just told me if I were to use the full 50 grams of NH3 that I started with, I could make a maximum of 79.4 grams of water. That's basically what this whole calculation is telling me. So going back to our sandwich example, that would be like saying, I'm trying to make turkey sandwiches, and I'm going to look specifically only at my bread, right? We're only looking at one reactant here. Let's say NH3 is comparable to your bread. If I used all of my bread, I could make 79.4 sandwiches. That's kind of what you're saying. So now let's focus on our other reactants. I'm going to look at O2 and do another mass to moles to mass calculation, connecting it back to the water. So I'm going to start with 100 grams of O2. Don't forget my unit. First thing I'm going to do is convert to moles. 1 mole of oxygen has a molar mass of 32 grams. Where did that number come from? That came from the periodic table. Now I'm going to look at my mole ratios. If I have moles of O2 here, that means I have to have moles of O2 down in my denominator to match. So I'm going to go ahead and put moles of O2 here. And again, where am I trying to get to? Well, I want to know how many grams of water I can make. I don't have a conversion to get straight to grams just yet, so I'm actually going to look at moles of water first, and then I can convert back to grams in a minute. Where do I go to find my mole ratio? Oh yes, that's right. It's in my balanced chemical equation. You must look at your coefficients. So the coefficient in front of water is 6, and the coefficient in front of oxygen is going to be 3. So I'm going to fill that in. 6 goes up top, 3 goes down below. Yes, you can simplify if you want to. Then I'm going to convert back to grams. You'll notice this last piece that I'm filling in here is going to look identical to the calculation up above. So this is identical here. You're just converting back to grams for water. That's all you're doing. Okay, so now we got to solve this bad boy. Punch in your calculator. 100 times 1 times 6 times 18. Then hit divided by 32, divided by 3, divided by 1. And you should end up with around 112.5 grams of water. Okay, that's a lot of math just to figure out one question. So basically what we're going to do is compare our 2 gram values. The question is, what's the maximum amount of grams of water that can be produced if you use those certain amount of starting reactants? You always have to pick the smaller value. It's your limiting reactant, right? That actually plays into number 2. The one that runs out in this case is going to be your NH3. I have enough NH3 to make exactly 79.4 grams of H2O and not one teeny bit more. Yes, I have enough O2 to make 112.5 grams of water, but I can't. Why? Because I'm running out after the 79.4 grams of H2, after the 79.4 grams is made of water. Okay, so let's go ahead and get some answers here. We're going to pick the smaller answer for number 1. Always choose the smaller value. So 79.4 grams of water can be made. Which was my limiting reactant? My limiting reactant, again, was NH3. So I'll just put an L, was NH3. And that means the one that was in excess is going to be my O2. So I'll just put an E, was O2. Awesome. Now, number 3 is another complicated question. It says, how much of your excess reactant is left over? Okay, so here we go. Now I'm going to do one more mass to moles to mass calculation, and I'm actually going to connect my excess reactant, which we decided was O2, and do a mass to moles to mass calculation and connect it back to my water. So I'm actually going to start with my 79.4 grams of H2O. And go from mass to moles to mass and kind of connect, again, this value back to my oxygen. That's That's my excess reactant. I want to know how much was used. So first thing I'm going to do is convert to moles. That's pretty simple. Water has a molar mass of 18. So 1 mole of water goes up top. Now I got to look at my mole ratios. So I know I've got moles of H2O as my numerator unit. That means moles of H2O has to drop down to match in my denominator unit. So I'll put moles of H2O here. And again, I'm trying to get to moles of my excess reactant, which in this case you just told me was your oxygen. So where do I go to find this molar ratio between oxygen and water? Again, I have to go back to my balanced chemical equation. Looks like we're going to have a 3:6 ratio here. So I'm going to put 3 up top, 6 down below. And then convert back to grams. So 32 grams of O2 will be up top. 1 mole of O2 is down below. Wonderful. My units are going to cancel. Everything looks good. How do I solve it? 79.4 times 1 times 3 times 32. Then in your calculator hit divided by 18, divided by 6, divided by 1. You should get something around 70.57 grams of O2. And I'm going to write used here just to help keep me straight. So what you just told me with this long calculation was if I were to make the full 79.4 grams of water, that's the max I can make from this reaction, how many grams of oxygen would I use? So this hasn't completely answered question number 3 because it wants to know how much is left over. Well, if I used 70.57 and I started with, what did we start with? Go back to your problem. It looks like we started with 100 grams of oxygen. All I have to do is a simple subtraction. So for number 3, I'm going to do 100 minus my 70.57 and end up with 29.42 grams of O2 left over. That was a doozy. Okay, we're still not done yet, and I'm running out of room here, so maybe I'll just start writing up here in this box in the corner. Number 4 says find the percent yield if actual yield is 77.6 grams. Well, we all know percent yield is actual over theoretical. I'm sorry, I'm writing tiny here. So our actual yield is given to us in problem number 4. It says 77.6 grams. And our theoretical yield, you already calculated. This is your theoretical yield, 79.4 grams. That's the max that you can make. So that's what's going to be my denominator, 79.4. Once you divide and multiply by 100, you should end up with somewhere around 97.8% if you round. Holy smokes. Okay, so that was a lot of math. Basically what percent yield tells you is if you actually mixed these two chemicals in the lab and you ended up with 77.6 grams, your reaction in that lab was about 97.8% efficient. You obtained about 97% of your results, which is a pretty decent percent yield, I'd say. You got almost all of your results. Okay, I hope this helped you. Go back and rewatch it. Go step by step, piece by piece if it didn't. These types of problems are definitely more of an honors skill that you will probably use in AP Chemistry or possibly Physics later on in the future. The key thing to remember here is mole ratios come from your balanced chemical equation. And then when you get your two final products here, which we were comparing gram values, you always have to pick the smaller one. That's where you're running out. Okay, good luck.